Hello student, welcome to AriserTalent. I am your math teacher Arpita Sharma. Okay, so in previous lecture we have discussed about a rational number, right? So I just told you to factorize these numbers in rational form, right? In P by Q format. Okay, so have you done that? Let's do it together. So we are having here 1, 2, 3 and 4 examples and we are going to solve each example one by one. And why we are solving this? I've told you. We are solving this because after solving these examples, we will make some conclusion, and in this conclusion and on this conclusion, we have some theorems waiting for us. Okay, let's start. The very first one is 375. Okay, it's 0.375, right? So, how will we rewrite it in P by Q form? We may write it 375 by 1000 because after decimal we are having 3 digits. So, we will put 3 zeros here. Okay. Now, factorize it. You may write it as 10 to the power 3 or this 375. We will factorize it. I have told you about this. 7 plus 5, 12, 13, 14, 15. Okay, so divisible by 3, 1, then 6. Okay, 5 times 15, 2, 5, again 5 times 155, 5. Okay, right. Now, we'll again divide it by 10, 11. So, not divisible by 2 and 3, it will be divisible by 5. Okay, 3 times, 1 time, then 31 times. Okay, so we will do the factorization of 375, not divisible by 2 but divisible by 3. Okay, 1 time 3, then 2 time 6, 1 left, 15, 5 times, 125, 5 plus 2, 7, 8. So, not divisible by 2, not divisible by 3, then 5. Now, 2 times, 5 times, again 5 times, then 5, here 5 and then 1. So, this will be the prime factorization of 375. Okay, we will write it in this form. 3, 5 multiply by 5. Now, how can you rewrite it? 3 into 5 raised to power 2. Okay, and this we can factorize it like 2 raised to power 3 multiply by 5 raised to power 3. So, this factor is in form of 2 raised to power 3 and 5 raised to power 3. Now, we have our second digit as 0.104. Now, again we will write in P by Q form. It will be like 10 to the power 3 and 104. We will do the factorization here. Divisible by 2, okay, 5 and 2, then divisible by 2, then 2, 6, then divisible by 2, 13, then because 13 is a prime number, so 1. So, what we will get here? 2 raised to power 3 multiply by 13. Okay, Now we can rewrite it as to the power 3 multiply 13 divided by 2 raised to power 3 and 5 raised to power 3, right? Again, the third term 0.0875. How can we rewrite it? 875, because we are removing decimal from here. So, after removing decimal, this 0 is of no use, but 1, 2, 3, 4, we will put 4 zeros here, right? Now, taking LCM of 875, 8, 7, 15 plus 5, 20. So, not divisible by 3. Okay. Divisible by 5 one time, 7 time, 2, 7 time. Okay. Now, not divisible by 2, not divisible by 3, 7, okay, here 5, okay. Now, divisible by 5, now again by 5, 3 times 2, 5. Now, 35, again divisible by 5, 5, 7 times, now 7 and 1, okay. So, we will write it in this form. Here 2 raised to power, directly we can write it 10 to power 4, and we can rewrite it in the form 5 raised to power 3 multiply by 7 and 10 to power 4, sorry, 2 raised to power 4 and 5 raised to power 4, okay. Now, we will take the fourth number. This is 23.3408. We will write it here 23.3408. Again, we will write it. We will remove decimal from here. See, 33408. Now, how many zeros? 1, 2, 3 and 4. 4 zeros are here. 1, 2, 3, 4. Now, again prime factorization. So, we will do it here. 2, 3, 3, 4, 0, 8 divisible by 2, 1 time, 6 time, 7 time, 0 time and 4 time. Again by 2, 5 time, 8 time, 3 time, 5 time, 2 time. Again by 2, 2 time, 9 time, 1 time, 7 time, 6 time. Again by 2, 1 time, 4 time, 5 times, 8 times, 8 times. Again by 2, 7 times, 2 times, 9 times and 4 times. Again by 2, 3 times, 6 times, 4 times, 7 times. Now, it can be divided by 7. Five times, 1, 4, 2 times and 1. Now, 5, 2, 1 is again a prime number, okay. So, we will write 5, 2, 1 here and it will end here. So, the prime factorization of 2, 3, 3, 4, 0, 8 will be 2 raised to power what? 1, 2, 3, 4, 5, 6. Multiply by 7, multiply by 521. Now, factorization of 10,000 will be, we can see the pattern here, 2 raised to power 1, 2, 3, 4 and 5 raised to power 4, right? Now, you are seeing something. We have taken some x numbers, some decimal numbers which are terminating. Okay, now we converted it in the form of p by q, and when we converted it in form of p by q where q is not equals to 0, what we saw, that the denominator is having multiple of 10 and the multiple of 10 is having prime factorization only 2, that is 2 and 5. The only possible prime factorization of 10 is nothing but 2 and 5. No other prime factorization possible. So, in each and every case, we are getting what? 2 raised to power sum and 5 raised to power sum. Let we call this particular 2 raised to power n and 5 raised to power m. So, these are all are in the form of 2 raised to the power n and 5 raised to power m. This is what I want you to focus. Now, I am removing this part. Okay. But I am leaving this part for you. We'll know it later why I am leaving this part. See, the theorem is here. With this, I told you what we have concluded, and what we have concluded is here. Let x be a rational number. Now, what I am trying to say, let x be a rational number. Now see, we have taken rational numbers whose decimal expansion terminates. So, this was our x. This time this, second time 0.104, third time 0.0875 and fourth time 23.3408 was our decimal terminate expansion. Okay. X be a rational number whose decimal expansion terminates. Then x can be expressed. Then x can be expressed in the form of p by q. We are expressed all in form of what? See, p by q. Okay. Where p and q are co-prime. Right? We are having, now in this conclusion, we are having some what? Numbers which are not co-prime. So, let's cancel out. That can be written as 3 to the power 3 multiplied by 5. Okay. This expression 13 5 raised to power 3. Next. Okay. Now left is 7 2 raised to power 4 multiplied by 5. Let's recheck. 3. Okay. 2 to the power 3. Cancel. 1 left. Here. Okay. We got it. 2 to the power 3. 2 to the power 3. Cancel. 13 left. Okay. 5 to the power 3 left. Okay. This cancel out from this, 5 remaining, 7, 7, 2 raised to power 4, 2 raised to power 4. Okay. Now, P and Q are co-prime and the prime factorization of Q is of the form 2 raised to power n and 5 raised to power m, where n, m are non-negative integers. So, the prime factorization of denominator, the prime factorization of denominator so the prime factorization of denominator will always be either in the power of 2 or 5 or both. Okay. When where n and m are non-negative integers. These are only positive integers, right? See this theorem very carefully, it's of your use. Next, we are taking these examples. These examples are nothing but the same expressions we have discovered here. Look carefully and you will identify. We have just simplified these and put it in P by Q form. We have already written it in P by Q form, but we have done what? Multiplication of these factorization and we changes it in this manner. Now, we are going to prove the reverse also, right? So, let's have a look. If you are multiplying this 3, okay, now 8 multiplied by 5, so in this example we are having these 4 decimals numbers. Okay, so now we will write it in P by Q form. Let's write 0.375, that will be equals to 375 upon what? 1030, because decimal is before 3 places. So we will write 3 digits here. So now we will do prime factorization of what? 375, right? So do this fast. 7 plus 5, 12 and then 3. Okay, so it is divisible by 3. 1 time, 2 time, 5 times. Then now 5 times, that will be 2 and 5 times. Then again 5 times, again 5 times. Okay, so what will be the prime factorization? 3 into 5 into 5 into 5, and prime factorization of 1000 will be what? 10 into 10 into 10, and prime factorization of 10 is 2 multiplied by 5. So 2 multiplied by 5, 2 multiplied by 5, 2 multiplied by 5 will eventually give you 3 raised to power, will eventually give you 2 raised to power 3 multiplied by 5 raised to power 3. Okay. So we will directly write it as 3 multiplied by 5 raised to power 3 and 2 multiplied by 2 raised to power 3 and 5 raised to power 3. Now, the second one is 0.104. Okay. So we will rewrite it again in P by Q form, where Q is not equals to 0. Now, factorization of 104. We will do this 2 times 5, 2 times 2, 6, 2 times 13. Now 13 is a prime number. Okay. So we will get 2 into 2 into 2 into 13. Again 1000. So prime factorization will be 2 raised to power 3 and 5 raised to power 3. Okay. Now we will write it as 2 raised to power 3 multiplied by 13 upon 2 raised to power 3 multiplied by 5 raised to power 3. Okay. Now, the third one, 0.0875. We'll write it like 875 upon. Now, decimal is before 4 places, 1, 2, 3, 4. So, 1, 2, 3, 4, 4 zeros are here. Now, prime factorization of 875, it's divisible by 3 or not? 14, 15, 15 plus 5, 20. So, no, not divisible by 3. Then 5, okay. 5 ones are 5, 3 left. 7 times. 7 times. Okay. Now, okay, right. Then 7, 7, 14, 1, 15. So, is it divisible by 7 or not? 7, 14, 3, 37. Okay. Five. तो 25 ही तो जाएगा. So, factorization of 875, 5 times, 5, 1s are 5, 3, 7, 7 times, 2 left, 5 times. Now, again with 5, 3 times, 5 times. Now, 5 times again, 7, okay, then 1. So, the prime factors will be 5 raised to power 3 multiplied by 7. Now, 10,000, what will be the prime factorization? 1, 2, 3, 4. So, 2 raised to power 4 multiplied by 5 raised to power 4. Okay. Now, the last one, 23.3408. 23.3408. Now, how will we rewrite it? 233,408 divided by 1, 2, 3, 4. 4 zeros are here. So, we will write in this way. Now, prime factorization of 233,408 by 2, 1, 1, 6, 7, 0, 4, again by 2, 5, 8, 3, 5, 2, again by 2, 2, 9, 1, 7, 6, again by 2, 1, 4, 5, 8, 8, again by 2, 7, 2, 9, 4, again by 2, 3, 6, 4, 7. Okay, now 9, 7, 12. Is it divisible by 3? 6, 4, 10, 7, 20. So, no, it is not divisible by 3. Then 5, no. 7, let's try. 7, 5 times 1, 2 times 1, 521. Now, 521 is a prime number. So, 521. We'll write it 2, how many times? 1, 2, 3, 4, 5, 6. So, 2 raised to power 6 multiply by 7 multiply by 5, 2, 1. Okay, I am rubbing this part. Even you will do this part in your rough part. 2 raised to power 1, 2, 3, 4, 4, okay, 5 raised to power 4. So, these are prime factorization, and what is common? That the denominator of each and every term is having what? Factors, factorization in form of some power of 2 and some power of 5. Let it call some power of n and m. So, each and every denominator of these decimal forms is having what? What? Form of 2 raised to power n and 5 raised to power m, where n and m are what? Positive integers, non-negative or positive integers. So, we will study it in a theorem form, and that is here. I will rub this part only. So, you can see we have taken these numbers, these all are decimals, decimal numbers. So, let x be a rational number whose decimal expansion terminates. The decimal expansion of each and every number here terminates. It never goes on and on and on in these 4 conditions, in these 4 numbers. Okay. So, terminates, then x can be expressed in the form of p by q, where p and q are co-primes and the prime factorization of q is of the form 2 raised to power n and 5 raised to power m, where n, m are non-negative integers. That this is what I told you by example. Now, if you are telling me, then we are having here 5 raised to power 3 and 5 raised to power 3 as common factors. So, these numbers are not co-prime. Just cancel it out. Even if you cancel it out, like here and here and here, the leftovers here in this case, in this case, in this case, in each case, you are having the denominator in the factorization of 2 and 5. Okay. So, this theorem is still true, right? Let me rub this part only. I am not rubbing this part. Okay, and we will write these term also here, 5 raised to power 3 by 7, 2 raised to power 4, 5 raised to power 4, 2 raised to power 6 by 7 by 5 to 1 by 2 raised to power 4 and 5 raised to power 4. Okay. Now, what we are going to do next is, have a look. We have these terms, 3 by 8, 13 by 125, 7 by 80 and 14,588 divided by 625. We have these 4 numbers, and in the previous section we were discussing 4 numbers, right? So what's the similarity? Look carefully. How can I rewrite it? This will cut by this. So 5, 2 multiplied by 2 multiplied by 2. 2 to the 4 to the 8. 8. The first expression. Now the second one. 13. Here we also got 13. 5, 5 and 5. 5 multiplied by 5, 25. Multiplied by 5, 125. So it will be 125. Then 5, we are having this common 5 to the power 3 here. So it will cut this power and reduce this power to 1. Okay. Now 7, 2 raised to power 4 multiplied by 5. We have 7 here. Okay. Now 2, 2, 2, 2 multiply 2 4 times. 2 to the 4 to the 8 to the 16. Now 16 by 5. Again 7 by 80. 7 by 80. Now the last term. This will cut this by 2 times. Okay. Now 2 raised to power 2 multiply by 7 multiply by 521 upon 5 raised to power 4. Now when you will solve this, it will be again 14588 divided by 625. So what I have done, I am taking the results from the previous section, right, and putting it in the starting of this explanation. Why? Because I am trying to prove that opposite of this is also true. I was having decimal number that time and proving that these decimal numbers can be written in the form p by q, and the denominator will be only multiple of 2 and 5, right? Now I am going to discuss this p by q form, and then will eventually convert it into and I will eventually convert it into decimal form, and I will prove that if this is the condition, it is going to terminate. It will be a terminative one. Okay. So now 3 by 8. 3 by 8 can be written in the form of 3 upon. How can we do the prime factors of 8? That will be nothing but 2 raised to power 3. Now we have to do what? We have to take denominator in the form of multiple of 2 and 5. Okay. So I will multiply it by 5 raised to power 3. By doing so, it will be converted in multiple of 10, and I can convert it in decimal form. So by doing so, I will write what? 5 raised to power 3 here also to balance this equation. So to balance this expression, now what I will do now? I will multiply it 5 multiply by 5 multiply by 5. And here it will be converted in 1000. So 25, 125, that this will be 3 multiplied by 125. Okay. Again solving it, 15, 7, 3, 1000. This will be 0.375. Mark it here. Now see, In this example, our first digit was 0.375. We are getting the same here, 0.375. Okay. Now, again, 13 by 125. This was the first one. Second one is 13 divided 125. How will we factorize 13? 13 is a prime number, so 13 only. And 125, that will be 5 multiplied by 5 multiplied by 5. So, we will write it 13 multiplied by 5 raised to power 3. So, it can be rewritten as so, what we are going to do, we will multiply 10 to the power 3 here and 10 to the power 3 here, so that denominator can become the multiple of 10 and we can convert this number into decimal. This is the way what we have used to make a particular number in its decimal form. Okay. So, we will solve it further. It will eventually become 1000. Now, 13. Now, 2 is 2 multiplied by 2 multiplied by 2. 4, 8. Okay. So, 8 will be here. So, this will be 24, 4, 104. 1000 here. So, it will become 0.104. Now, I am practicing this third point here. Fourth you have to do on your own. 7 by 80. Now, how can I rewrite it? 7 prime factorization is 7. Now, 80. 2 multiplied by 2 multiplied by 2, that is 2 to the 4 to the 8. Multiply by 2 multiply by 5. Let's check. 10 2 to the 4 to the 8. 8 multiplied by 10, 80. Okay. Now, this will be written as 7 divided by 2 raised to power 1, 2, 3, 4. 4 and 5 raised to power 2 only. So, what we need? 5 raised to power 2. Okay. So, here we will also multiply it by 5 raised to power 2. Now, what will it become? 25. Here, that will become 10,000. Okay. So, multiply 7 by 25, 35, 3, 14, 15, 16, 17, 175 upon 10,000. That will be nothing but 0.0175. Okay. Fourth, we will do on your own. Now, we have taken these examples. Okay. Now, 1, 2, 3 and 4. So, 7. Now, 2 raised to power 4 and 5 raised to power 1. Now, we will multiply it by 5 raised to power 3. So, in numerator also we will multiply it by 5 raised to power 3. Now, resolving it, 7 multiply by 5, 5s are 25, 5s are 125. Okay. Now, it's 4 times by 5 and here it will be 10,000. That will be 7 multiplied by 625. Okay, let's recheck it. 7, 2, 2, 2, 2 and 5. Now, it will be 10,000 7 multiplied by, let's read on it. Okay, we have given this. Now 1, 2, 3, 4, 7 divided by 2 raised to power 1, 2, 3, 4 and 5 raised to power 1. Now we will multiply it by 3. So it will also be multiplied by 3. Right. Now in next stage we'll multiply 5 by 5 by 5 and it will become here 10,000. Now 5 by 5 is 25, multiplied by 5 is 125. 7 multiplied by 125 upon 10,000, it will be what? 35, 5, okay, 3, 14, 15, 16, 17, 7, 1, 8. It will be 875 upon 10,000. So, what will it become? 0.875, 0.0, because we are having 4 zeros here, right? Now, see that we are having first fraction as 0.375, second one as 0.104, then this third one as 0.078. Now we will compare our answers. So first one is 0.375, second one is 0.104, third one is 0.0875, right? Now we took some P by Q forms, okay, and here what we converted into a form of decimal that terminates. So what I wanted to show you by these expressions is this theorem, let x is equals to P by Q, let x is equals to P by Q, because in this form we took what? 3 by 8 P by Q format, 13 by 125 P by Q format, 7 by 80 P by Q format, 14,588 by 625 P by Q format. Okay, such that the prime factorization of Q is the form of 2 raised to power n and 5 raised to power m. We converted it into this format where m and n are non-negative integers. I have told you. Then x has a decimal expression which terminates. So if we can convert this form into a form of P by Q such that the denominator Q is having 2 raised to power n and 5 raised to power m as its denominator's factorization only, then only this expression x terminates, otherwise it does not terminates. Okay, students? Now, moving forwards. Now, we are having a number 1 by 7, okay, and we will do what with that? We will simply divide it like we used to do from our class 5th and 6th, okay. Now, 1, 7, it cannot be divided, so we'll put decimal here and we'll borrow a 0 here. Now 7 ones are 7, 3, again 0, 3 times 21, 4 times 28, 2, 0 again, 2 times 14, 7, 0, इसको वापस से करते हैं. Okay, we'll divide it simply 1 and 7. Okay, so we need to put a decimal here. 0, 1 time 7, 3, 4 times 28, 2, 2 times 14, 6, 0. Now 9 times, 8 times, 56, 4, again 0, 5 times 35, 5, again 0, 7 times. Now stop here. Why? Because we are having 1 as our remainder. We have to see only the remainder here. Okay, because this question is never going to stop. It will never terminate. So what we will do? We will see the pattern, the remainder. Now here remainder is 3. Here remainder was 2. Then 6. Then 4. Then 5. And then 1 again. So what I will do? I will put 0 here and the process will start again and there is a cycle that will never stop. So what will be the value of 1 by 7? It will be nothing but 0.142857. Then again 1, 4, 2, 8, 5, 7 and continued. So basically what is happening? 0.142875. This number repeats, so we will put a bar on it. We'll call it bar. Okay. Now, what's happening? Because we have studied that if a particular number is in the form of P by Q, then it will be terminated only if the denominator is in the form of 2 raised to power n and 5 raised to power m. Now, look at this number 1 by 7. The denominator here is not in the format. So, this shows that what if the denominator is not in the form of 2 raised to power n and 5 raised to power m, this will happen. This will not going to terminate. Okay. So, what our conclusion is? Let x 1 by 7 is x. Let x equals to P by Q be a rational number such that the prime factorization of Q in our example Q was 7 is of the form 2 raised to power n and m raised to power 2 raised to power n and m raised to power m, where m and n are non-negative terms. So, what I have studied you here by 1 by 7 is nothing but let x equals to p by q, where p and q are co-primes, be a rational number. In that case, x was 1 by 7, so q was 7, such that the prime factorization of q was not in the form of 2 to the power n and 5 to the power m. 7 was not in the form of this, okay. Where n and m are non-negative integers, we know that, then x has a decimal expression which is non-terminating and repeating or reoccurring. So, we have discussed it with that example. Okay students, we will do this exercise in our next lecture. Okay, so revise all these things and be ready to do some exercise, some questions, not only based on this, but whatever we have read in our complete chapter number 1, that is real numbers. Okay, thank you, keep watching.